Hey everyone, Mr. Skelton here. We are back at it, lesson 6, unit 5. Today we're going to be solving equations with square roots or with radicals, all right? And so the biggest thing that I can stress to you before we start today's lesson is that you are solving equations, right? So we should be thinking about how do we solve equations with opposite operations, right? Or what we call in math technically inverse operations. Right? Opposite of add, subtract, opposite of divide, multiply, opposite of multiply, divide, etc., etc. Now we're talking about square roots, right? So we're going to, if you look at the problems here, we have square roots. So be thinking about what's the opposite of something that is square rooted? Something that is squared, okay? And so that's what we're going to be doing here. We've done a lot of problems in the past unit where we had if something is squared, then we square root, and now we're just going to be working backwards. So as we get started, this should be a pretty quick lesson here for you. The one thing that is of utmost importance when you're solving these and where students make mistakes is that you need to make sure that you isolate the radical first before squaring both sides. That is important. Okay? That is really, really important when you do these problems. So, for example, if you look at number 1 here, it says to solve, which means we're trying to get x by itself. When I say isolate the radical symbol, that means nothing else can be around this symbol on the left side of the equal sign. And so what we want to do then is we want to subtract this 2 from both sides, which gives us then the square root of 3x minus 2 equaling 4. Once we have the radical symbol isolated, which we do here, then we can go ahead and square both sides. Squaring something squared just leaves you with what's underneath, so we're just left with 3x minus 2. 4 squared is 16, and now it turns into a regular algebra 1 equation. We add 2 to both sides, we get 3x equals 18 divided by 3, and x would equal 6. And you can always check your answer. Plug in 6. 3 times 6 is 9. 3 times 6 is 18. 18 minus 2 is 16. The square root of 16 is 4, and 2 plus 4 is 6. So it works. Go ahead and hit pause and try number 2 on your own, and check back with me when you're finished. All right, so we need to isolate this radical symbol. So I have the minus 6, which is outside, so we want to add this 6 to the other side. So we have 5x plus 1 underneath the radical symbol equal to 6. Once we've isolated it, then we need to square. You don't have to put the parentheses on there. I just kind of do that out of habit sometimes. So we're left with 5x plus 1 because the square and square root undo each other. And we have 36. And we subtract 1. 5x equals 35. So x equals 7. Again, you can check that real quick. 5 times 7 is 35 plus 1 is 36. The square root of 36 is 6, and 6 minus 6 is 0. On the back, we have just 2 more problems, and it's just a different variety of problems. So you'll notice here on number 3, some of you may be wondering, well, how do I isolate the square root symbol? Both sides have a square root symbol. If that is the case, you are going to square both sides right away. And again, all that does is squaring a square root symbol cancels itself out. Those are opposite operations or inverse operations of each other, and you're just left with what's underneath the radical sign. And you're left with 5 minus n equals 2n plus 11. I like to keep my variables positive, so I would subtract 11 and add the n. So I would get a negative 6 here, equaling 3n, and dividing by 3 and getting negative 2. Okay? There. On this one here, I'll have a lot of students who try to divide by 5 or to divide by 10 on both sides because it's to try to isolate one or the other. And you could do it that way. You can also just square both of these right away. Watch what happens when you do that. Remember, this is really 5 times radical 2n, and this is really 10 times radical 3. So if you square both of those and you obey your exponent rules that we learned, remember, this squared goes there and here, so this becomes 5 squared. This becomes just 2n. This becomes 10 squared, because that's got to go here and here. and that becomes just 3. So you get 25 times 2n equals 100 times 3. So you get 50n equals 300, and you divide by 50, right? And so then you're just going to get n equals 6. Okay? So pretty basic stuff here, nothing too crazy, I don't think. You may still find some struggles with one or two of them, but all in all, you should be okay. As always, if you have questions, make sure you ask in class. I'd be happy to help you out.